Tēnā koutou katoa. Welcome to the seminar today in the Puna Haumaru seminar series. Today I'm really excited to introduce to you Dr. Zarina Vakhitova, who is an Australian Research Council Discovery Early Career Award winner and a Senior Research Fellow at Monash University. She has expertise in the intersection of technology and crime, focusing on how technology facilitates, mitigates, and prevents criminal activity. Zarina has an extensive publication record in leading international peer-reviewed journals, including Computers and Human Behaviour, Crime and Delinquency, Policing and Society, and Crime Science. So it's fair to say we're hearing from an expert in the field, and I'm really excited to hear about this talk.
So yes, thank you everyone for coming to hear my talk. Today I'm going to present the findings from the recent study that my colleague, Professor Claudio Mazzetti from the School of Economics at University of Queensland and myself completed. The paper based on the findings from this study has been accepted and will be published soon in Crime and Delinquency. But today we're going to talk about sort of the link between emotions, ransomware, and the decision to pay or not to pay in ransomware attacks. So I'm going to present results of a survey, a Factorial survey experiment that basically tried to manipulate the ransomware condition, see whether this ransomware condition changes or affects the emotions that people experience, the victims of ransomware attacks experience, and whether these emotions in turn affect the decision to pay or not to pay. So before I begin, I would like to give you a very quick definition of what ransomware actually is. It's a form of malicious software that is deployed by cyber criminals to block access to users' computer systems or to encrypt data and files to prevent access and or facilitate theft of data held on systems or devices. And more recent sort of development is this data could be sold on dark web following the exfiltration. So the reason why my colleague Claudio Mazzetti and I, we were particularly interested in ransomware is that ransomware is a very unique type of crime. It's a type of extortion, and we are all familiar with extortion types of crimes, such as a kidnapping for ransom, something that used to be more common, much less common now. And another type of crime of similar nature is, for example, sextortion, which is becoming much more common now. Image-based abuse, all of these crimes where victims are extorted some sort of value. Some sort of value is extorted from victims. It could be monetary value, it could be services, it could be, images, all sorts of things. And the really interesting thing about ransomware and any types of extortion is that unlike most crimes, the success of this type of crime is almost entirely determined by the victim of the crime. So it is the victim who decides whether ransomware attack is successful or not. By either paying or not paying the ransom, basically victims determine the success or the successful outcome or failure of ransomware attack. And what makes ransomware extortion is particularly interesting is it's the victim's decision making that makes this crime so interesting. For example, if let's compare just a general data breach to ransomware attack. In a data breach, the computer system is exfiltrated. Hackers take stuff that they want from your computer, and maybe they can sell it later. Maybe they use it for some other purposes. But victim is basically not involved in any of these activities. What victim does doesn't really affect the outcome. But in ransomware, if the victim decides not to pay, the ransomware basically failed. Now, we both, Professor Mazzetti and I, were very interested in decision-making, and victims' decision-making in particular, and that's why we decided to work on this study. Now, besides the fact that this is a very interesting type of crime, ransomware is actually a very dangerous crime and very potentially problematic issue. I'm going to give you some statistics about the prevalence and costs associated with ransomware. Now, please be aware that these are very conservative estimates of prevalence and the costs, simply because I'm sure you're all aware of the dark figure of crime. In cybercrime, in the case of cybercrime, dark figure of crime is particularly huge. And in most cases, we really have a very little idea about, that hidden part of crime. Victims of cybercrime very rarely report crime to the police, and even in surveys, there's issues associated with feeling guilty, ashamed. So even in those cases, they very often don't admit experiencing cybercrime. In ransomware crime, this problem is particularly significant because very often ransomware victims are companies, organizations, agencies, government offices, etc., etc. So those organizations are very, very rarely actually surveyed at large. So we have a very vague idea about the prevalence and the extent of the problem. But this is just some data that I've found, and I think it's it's conservative, but I think it's believable to a degree. So according to the Office of the Director of National Intelligence in the United States, in 2024, $813 million US was paid in ransoms worldwide. I think that's highly underestimating the actual figure. The average payment, according to the same source, is between $1 and $2 million US. Obviously, probably skewed, but median payment is still pretty high. So we're talking about $400,000 per payment. Now, obviously, large amounts. And of course, ransomware the cost of ransomware doesn't stop at the actual payment of the ransomware. So, or of the ransom. Even if the company decides not to pay, there's going to be costs involved in restoring the systems, in reputation, in restoring damaged reputation, etc., etc. So the costs of ransomware are significant. Now, what's particularly troubling about all of this is, according to FBI, and I believe this is highly, this is the lower sort of bound estimate, 49% of victims, so basically half of all victims that they know about, paid ransoms despite the official advice not to. So the official advice from FBI is always do not pay the ransom. Easier said than done, but even with this official advice not to, 50% of victims admitted paying the ransom. And I think this is underestimating it. I've seen some sources that basically talked about up to 89, 90% of all victims actually paying the ransom. Obviously, if all victims stopped paying ransomware as a business model would just cease to exist. And the fact that ransomware persists tells us victims are paying. So now the ransomware could basically anyone could become a victim of ransomware attack, but in more recent times, and we actually wrote another paper which will be published in the same special issue in Crime and Delinquency, the special issue on financial crime. And we did a study where we basically followed up the evolution of ransomware payment methods. And what we noticed that this story of, $25 sort of gift card, iTunes gift card type of ransomware attacks, that's a thing of the past. These days, ransomware is becoming much more commercialized. It's becoming basically very organized and very serious crime, where ransomware attackers specifically pick targets. They're not just throwing the wide net and see who gets caught in this net. Instead, they're looking at high value targets. We're talking about healthcare, like hospitals, insurance companies, schools, government systems. What's kind of in common amongst all these high value targets, they usually have money. They usually have access to very sensitive private information, and they usually invest in cybersecurity. So financial institutions would be a great target in the sense that they have money and they have sensitive information, but they usually are much more cybersecurity aware than these types of organizations. Now, this is an example of sort of a very serious ransomware attack. This article talks about an attack on Change Healthcare insurance company. As a result of this attack, the victim ended up paying $22 million US dollars in payment for ransom. As you can see, it says the transaction visible on Bitcoin's blockchain suggests the victim of one of the worst ransomware attacks in years may have paid in a very large ransom. You may be familiar with Change Healthcare because a couple of years ago, maybe you remember there was this case on all newspapers and news media involving Luigi Maggioni, who allegedly shot and killed the CEO of United Healthcare, which is a subsidiary of Change Healthcare, Brian Johnson. So, yeah, probably not the best time to be in health insurance at the moment. So anyways, so that's one of the reasons why we chose healthcare sector and the victim in this sort of field as a central figure in our own research. Healthcare seemed to be under attack for ransomware attackers. They, healthcare, especially insurance companies, they have such sensitive information about millions of people, and they have money. Okay, so now despite the fact that clearly ransomware is becoming a serious problem, and there's a lot of sort of attention is being paid to this field, trying to figure out what can we do with ransomware, how can we prevent it, and what should victims do if they do get attacked. Most of this research always assumes that victims are going to be fully rational, that the only thing that victims will do is they will sort of weigh pros of paying the ransom versus costs of not paying the ransom. So existing research basically focuses on this very narrow monetary cost-benefit analysis that victims undertake. And victims do undertake that analysis, that is without a doubt. But is this the only thing that they do? Imagine you are under a very serious ransomware attack. You're definitely going to be very stressed. That stress could cause your decision-making to be affected by these strong feelings. And these feelings could be anything, could be fear, anger, shame, guilt. So we were obviously not the first people to think that these incredibly stressful events are probably likely to affect decision-making of the people under stress. For example, George Lowenstein and colleagues, they came up with this idea of risk as feelings framework, which basically challenges traditional models that view risk as purely cognitively assessed probabilities and outcomes. So if you look at any economics research, it's always this assumption people will be doing cost-benefit analysis, and if the costs outweigh the benefits, they are not likely to engage in these activities, and so on and so forth. But risk as feelings framework actually argues that emotional responses often dominate decision-making under risk, and that these emotional reactions to risk, for example, fear, anxiety, anger, guilt, shame, they can affect cognitive evaluations. So the idea is, if you're making a decision about something in a normal, non-stressful situation, you are much more likely to think rationally. But if you are under a huge amount of stress, maybe your job is on the line, maybe it was your responsibility, maybe you were responsible for cybersecurity strategy in the company, and then company gets attacked, or you're worried about the lives of patients in the hospital, you might be worried about something else. These emotional reactions are likely to contribute to your decision making and your decision to pay or not to pay the ransom. So that's the basic idea for our study. Now, as I said, most of the research is focusing on pure rationality, and there's hardly any research that's looking at the effect of emotions in these high stress situations on the decision-making of victims, and in particular victims of ransomware attacks. So to sort of address this gap, our research study is trying to answer three research questions. First of all, we want to know to what extent the extortion mechanism affect ransomware victims' decision to pay or not to pay. So we were looking at sort of three conditions: a neutral condition where there's no ransomware attack, the condition in which the ransomware attack produces locked files, so they're encrypted, you can't use them, and the condition where the files are stolen with possibly a purpose of reselling it on the black market, or maybe making it public that the offenders are holding your data, and that the private data is now being made public, for example. So we wanted to know whether this extortion mechanism affects the victim's decision to pay or not to pay. We also wanted to know how this extortion mechanism affects victims' emotional responses. We were curious whether locked files or stolen files would cause victims to experience heightened emotions. And we also wanted to know how do specific emotions such as fear, anger, shame, and guilt influence victims' decision to pay or not to pay in the incidents of ransomware attacks. These four types of emotions were basically extracted from literature. These are known emotions that victims of crime experience. Now, to answer these research questions, we designed a pre-registered between subjects vignette experiment with 1,447 participants. So we pre-registered the hypothesis. I will give you the hypothesis in a few seconds on aspredicted.org for basically replication and transparency about our own sort of thinking about this whole issue. We conducted the survey experiment on Qualtrics platform. We recruited the sample using Cint. Cint is sort of like an aggregator of online samples. for our sample, we recruited only adults, 18 years of age and above, and only US residents. Even though our sample is not random, we tried to make it broadly representative sort of general US population by using sort of quarter sampling. So we made sure that we have approximately similar proportions in our sample based on age, gender, and location. So we got 50-50 gender. Average age is about 48, which is similar to what the census of US population would tell you. And these are some other characteristics of our sample. So some sort of what you would expect. We're not in any way, shape, or form saying that this is representative sample, but we try to make it as close to what we would expect to see and give every group of within the population, at least demographically, a chance to be there. So all of the analysis were conducted in R. Now, I'll show you the vignettes that we have created. So we had 3 different vignettes. First one was zero condition, neutral. As you can imagine, it is difficult to design a no ransom situation. So this is as close as we could come up with. So this was the text shown to our participants. Imagine you are the head of cybersecurity for a mid-sized hospital. You have received a request to complete a survey about how to respond to a ransomware attack targeting patients' data. One of the survey questions is whether the default hospital's policy to ransomware attacks should be to pay or not to pay the ransom. How would you answer this survey question? And basically, the participants had to choose whether they say pay the ransom or not pay the ransom, which is our basically main dependent variable. Now, the second condition, which was representing locked files or what's the word? Doesn't matter. So the files that were encrypted. Now, the beginning of the vignette says basically you are the head of cybersecurity. Your IT department has informed you that your network has been attacked by a criminal ransomware organization. This is not a scam. The attack could cause millions in financial, legal, and reputational damages, disrupt critical care services, and put patients' lives at risk. You need to decide how to respond to the following attacker's demand. And this is the demands. We have locked all your patients' records, diagnostic files, and financial documents. Send $1.2 million in Bitcoin to the address provided, and we will send you the key to recover your data. If you try to fix this yourself, you will damage your files forever. We always keep our word as we value our reputation. And then, of course, the participants had to choose pay the ransom or not to pay the ransom. The only thing is this red box, we made it sort of flash to kind of create the sense of sort of danger. Anyways, and the last condition was stolen files. The beginning is basically almost the same. Now, this is the threat condition. We have stolen all your patients' records, diagnostic files, and financial documents. Send 1.2 million in Bitcoin to the address provided. If you do not follow our instructions, we will sell all the data in the dark web market. We always keep our word as we value our reputation. I have to mention something that the text of these ransomware notes was this text was constructed based on our own analysis of a large sample of real ransomware notes that we have been able to collect. So this is kind of similar to what you will actually see in real life. Interestingly enough, they always talk about their reputation. But anyways, so this is basically based on these real world notes. So these are the 3 vignettes. After the participants in our experiment were shown their own vignettes, so it's between participant analysis. So each participant was only shown one vignette. After they were shown the vignette, we asked them a question about their emotions. Immediately after reading the question, to what extent did you experience each of the following emotions? And if you didn't experience any emotion, please select not at all. So I felt angry, I felt scared, ashamed, guilty, and I felt other emotions. These are the 4 hypotheses that we have developed based on our understanding of the topic, basically on reading the literature. So hypothesis 1 is we basically believe that the ransomware note condition will affect the odds of paying the ransom. So we were not sure which way the effect is going to go. We didn't know whether it's the locked files or the stolen files that will affect the payment decision making. That's why we didn't make it directional, but we were pretty sure there will be some effect. Then, at least in comparison to the neutral condition. The second hypothesis was that specific emotions such as fear, anger, shame, and guilt will affect the odds of paying the ransom. Here we were a little bit more clear about the effect because the literature is fairly confident about it, at least on some things like fear and shame. We expected to increase the odds of paying. Anger, we expected to decrease the odds of paying, and the direction of guilt was uncertain because we had literature that showed it increased, and then we had some other literature that decreased the odds of sort of reactions. So we left it uncertain. The third hypothesis was that the ransomware note condition will affect the emotions reported by the participants. And sort of the final hypothesis here is sort of like this mediation hypothesis that the effect of ransomware note condition on the decision to pay will be mediated by the emotions it elicits. So basically we thought, okay, you see the note causes you to experience emotions. These emotions affect your decision to pay or not to pay. That was our predictions. So this is just a very quickly mediation model. As you can see, so there is all 3 hypotheses are in it, and altogether is a mediation model. The condition which is specifically neutral, locked files or stolen files, is our exposure. Our payment, whether you decided to pay or not to pay, is the outcome. And various emotions, fear, shame, anger, and guilt, are the mediators. Now, just very quickly, I'll go over the analytical strategy. The hypothesis 1, let's go back to the hypothesis 1 is basically the effect of condition or the ransomware note on the payment. Because payment is a binary variable, we used a logistic regression where basically these 2 parameters are the condition either locked files or stolen files, and the last parameter in this model is the vector of control variables. We've included a bunch of covariates. Despite the fact that we have randomized our participants to different conditions, there's always a chance that this randomization is not perfect. And it might be randomizing on some demographic characteristics, but some of the variables that are of particular interest to us, they may not have been properly randomized, and it's always good to control for them anyways. So for hypothesis 1, because basically hypothesis 1 is the effect of emotions on the payment, again, the dependent variable is binary variable, so it's another logistic regression where we include the effects of fear, anger, shame, and guilt, and the control variables. And the hypothesis 3, which is the effect of condition, the type of ransomware note on emotions, is basically emotions are measured on the continuous or like pseudo-continuous variable scale from 0 to 100. So that's why it's a set of linear equations where condition, so DI1 and DI2, and control, and an array of control variables. We're looking at the effect of these things onto fear, on anger, on shame, and on guilt. And basically, the fourth hypothesis, which is mediation hypothesis, combines equations 3 to 4 and the logistic regression, where we're looking at the effect of condition and emotions, and as well as a set of control variables. So what causal mediation analysis, there's a paper by Kosuke Imai and colleagues where they basically introduced this new causal mediation analysis. Now, really quickly, I would like to acknowledge the fact that because we did not randomize emotions, we can't talk about the causal effect of emotions on payment, although we can talk about the causal effect of condition on payment. But because part of that mediation model is not causal, we're not really talking about causal effects. Trying to be careful here. So what the causal mediation analysis allows us to do is it allows us to sort of separate the indirect effect, which is average causal mediation effect, so the effect of condition through emotions, from the direct effect, which is average direct effect. That's the effect of condition on the payment. And it also allows us to see the total effect, where we combine indirect effect and direct effect on decision to pay or not to pay. These are the covariates we've collected together with our experimental variables. We measured age, gender. One of the things we were sure it was going to have effect is this trait anxiety measure. So basically, we measured a latent factor score from the generalized anxiety disorder, GAD-7 scale. So basically, the assumption was that people who are generally anxious are much more likely to be triggered by ransomware notes and much more likely to experience some sort of emotions. We were not sure which ones. We kind of expected it would probably be fear, but we wanted to make sure that we control for that as well. So we also included cybersecurity efficacy, latent factor score from items assessing self-perceived confidence in preventing and responding to cyber threats. So assumption is if you are very confident in terms of cybersecurity, you probably will experience less. At least that was our thinking. You will experience less emotions. You will be more calm and collected. Also, the same idea was behind cybersecurity training. This was variable constructed from basically a number of distinct cybersecurity training types previously completed. We've all taken some cybersecurity training if we work for government or if we work for university or if we are the cybersecurity experts. That could include 4-year university or college degree. It could be vendor-specific training like Cisco Networking Academy. There could be things like, online courses, employee mandated courses. We had like a variety of different things. So we measured how many different types of cybersecurity trainings our participants undertook. And then ransomware experience. Prior exposure to ransomware categorized as no experience or experienced but did not pay and experienced and pay. So that was sort of categorical kind of variable. And also risk tolerance, single item measure adopted from economic risk preference scales. So basically, we asked participants if you had, let's say, $100 and you wanted to invest it into 3 different types of investments based on their risk. Low risk investments, medium risk investments, we gave them some examples, and high risk investments. What percentages would go into, they would invest this $100 into, let's say, and we also multiplied, there was a multiplier like medium risk would be multiplied by 2, and high risk would be multiplied by 3. So that was our risk tolerance variable. Now, basically all of these variables that were not binary, we standardized using Andrew Gelman's approach by, it's basically scaling approach by dividing by 2 standard deviations, each of these values. What that allowed us to do is basically convert sort of continuous kind of variables, each one of them on its own scale. That allowed us to convert them all kind of like to binary variables. So cybersecurity efficacy becomes, are you cybersecurity efficacious or not? Do you have cybersecurity training or not? Or like basically you are very well trained or not? Threat anxiety, the same, and risk tolerance. So now let's look at the results of the study. The hypothesis 1 was basically let's remind ourselves what was the hypothesis 1, that ransomware node condition will affect the odds of paying the ransom. Now let's look at the results. I don't know if you can see it, but the 95% confidence intervals, these are the marginal means. Now the 95% confidence intervals between neutral and locked files do not overlap, which means there's statistically significant difference in the probability of predicted probability of payment between neutral condition and locked files. As you can see, locked files and stolen files, confidence intervals, they overlap, so there's no statistically significant difference between locked and stolen files, and there's no significant difference between neutral and stolen files. Now, what's really interesting and surprising, it was totally surprising to us, that people in the neutral condition were much more were statistically significantly more likely to pay the ransom than people in locked files condition, and slightly slightly more likely to pay than people in stolen files condition. So that tells us, yes, there is support for hypothesis number 1. That's the same kind of thing, but when we look at sort of like this is regression analysis, logistic regression, as you can see, we're controlling for a variety of different variables, and the only things that are don't cross the zero line are locked versus neutral condition, age, ransomware experience not paid, and huge effect size for ransomware experience paid. And also a little bit of risk tolerance. So now what's interesting, people who paid ransom in the past, they were attacked and they paid ransom, they were 10 times more likely to pay again, to say that they would pay again. Now, ransomware people who experienced ransom and didn't pay were also more likely to say that they will not pay again, but not as the effect size was smaller. Now, hypothesis 2 was about the effect of specific emotions on the odds of paying the ransom. Now, let's have a look at the results. These are basically this, what's the word? Hierarchical logistic regressions predicting ransom payment, the effects of discrete emotions. And what's really interesting, fear and anger have statistically significant effects on the probability of paying, on the odds of paying the ransom. And what's interesting, fear roughly sort of doubles the probability that the person will say, I will pay, and anger roughly halves the probability that the person would say, I will pay. Now, interestingly enough, the results sort of the effects of someone who experienced ransomware in the past and not paid, and paid in the past. So the effects of emotions are still statistically significant even in the presence of these very, very strong, very high effect size variables. Everything else is basically no effect. So gender, risk tolerance, kind of, once you start controlling for all these things, disappear, and the effect of shame and guilt is basically not there. The third hypothesis was about the effect of condition on different types of emotions. We were sure that the conditions, the locked or stolen files, will have some sort of effect on emotions. And we were correct. As you can see, condition locked versus neutral has an effect on anger. So locked files make you more angry compared to neutral condition. They also make you more fearful than neutral condition. Stolen files, the same idea. Shame and guilt, basically nothing to write home about. Prior experience, again, is statistically significant. When you experienced ransomware in the past, you're more likely to experience all of these emotions. Cybersecurity efficacy also makes you, well, in this case, makes you more angry. Anxiety is definitely makes you more likely to experience all of these emotions, in particular fear, shame, and guilt. So that's all kind of along the lines of what we expected. Now, really quickly, the mediation analysis. So basically, we were able to disassemble the mediation by discrete emotions, the effect of these discrete emotions on the risk difference scale. And what's interesting, only anger. So basically, it's that indirect path. Only anger mediates some of the effect of the condition on paying or not paying the ransom. So in the locked versus state versus neutral condition, 18% of that effect is mediated through anger. Slightly less is mediated in the stolen condition, stolen versus neutral condition. About 16% of the effect of condition is mediated through anger. Now, there's a lot of numbers, lots of tables and figures. So before I finish this presentation, I want to sort of put it all together and tell you what these our findings actually tell us. So first of all, experimental condition matters. So whether it's locked files or stolen files, that is important. When people read a coercive ransomware note, whether we're talking about locked files or stolen files, they were less likely to say that they would pay compared to those making an abstract policy judgment. We don't know why, really. It seems counterintuitive. The locked files condition produced the clearest reduction, roughly 9 to 11 percentage points. So the content of ransomware message itself shapes the decision. Okay, so there is a reason why ransomware notes are written the way they are. They are written to make you more likely to pay. For some reason, it works the opposite way. Now, second, the emotion also matters. The emotions matter a lot. Now, fear and anger emerged as two most influential emotions. Shame and guilt a bit less, but they push in opposite directions. This was unexpected. We didn't really see this coming. Fear roughly doubles the odds of paying, and anger roughly halves them. Guilt has a smaller positive association with payment, and shame didn't reach significance. This is important because it tells us that victims don't just calculate costs and benefits. The emotional state at the moment of decision is strongly linked to what they choose to do. How do these pieces fit together? Our mediation analysis shows that about 16 to 18% of the condition's effect on payment operates through the emotional pathway, specifically through anger. The ransomware notes increase anger, and that anger is associated with refusing to pay. That is the mediated component, but there's a important point here. The role of emotions in this study is actually bigger than this 16 to 18% suggests. Emotions don't only matter as a channel through which the node content operates, they also explain substantial variation in payment decision within conditions. Two people can read the exact same ransomware note, but if one reacts primarily with fear and the other primarily with anger, they will make very different decisions about payment. So that individual level variation in emotional response is one of the strongest predictors of payment in our models. It is stronger than cybersecurity training and stronger than risk tolerance. So why is mediated share relatively modest? Okay, there could be several reasons. First, our experimental manipulation moved emotions by only a small amount on average, about a fifth to a third of a standard deviation. That's a real effect, but it's modest in terms of the size compared to the enormous variation in how individuals naturally respond emotionally. And second possibility is that this is a limitation that we acknowledge, that a survey vignette simply cannot reproduce the intensity of a real ransomware attack. Obviously, the participants knew this was not a real ransomware attack. We were surprised by the fact that there was an effect, and people in two different conditions, ransomware conditions, looked different to neutral condition. So in the field where patient safety, livelihoods, and reputations can be generally on the line, we would expect emotional reactions to be far stronger and therefore more consequential for decision making. So our estimates are almost certainly a very conservative lower bound. One more finding I wanted to highlight is this prior experience with ransomware, one of the strongest predictors. As I said, people who had paid a ransom before were roughly 10 times more likely to say that they would pay again. This suggests a behavioral precedent effect. Once an organization pays, it may become predisposed to paying again, which has clear implications for institutional policies. And finally, cybersecurity training, which was kind of surprising to us, at least as we measured it, showed no measurable effect on payment decisions. Maybe some types of cybersecurity training might have bigger effect. This suggests that current training programs, at least based on how we measured it, which tend to focus on technical hygiene and threat recognition, may not be preparing people for the psychological realities of an actual extortion event. And the bottom line is this. So ransomware decision-making is not purely rational. Emotions play a meaningful role, both as a pathway through which the attacker's message influences behavior and as an independent source of variation that shapes whether victims comply or resist. So policy and practice need to account for both. That concludes my presentation. Thank you very much for your attention.